Now, let's go back to section 1, and let's solve some examples, right? So we want to find all complex solutions and write our solutions in complex standard form. So what's complex standard form again? It is A plus BI, right? So the very first example, right, I have x squared plus 3x plus 4 is equal to 0. Right? So the reason why I talked about finding the discriminant of a quadratic equation first is because I think it's helpful to calculate the discriminant first so you understand or you know what kind of solutions you should be getting. Because even if it says complex roots, what does that mean? It means, remember that the complex numbers, it is all the real numbers, and it's also the ones that have I. So even 3, this is considered a complex root because, just because it just is. That means just B is equal to 0, but this is still complex. And then like 3I is complex. So when it for these, for this section, even though it says complex roots, it does not necessarily mean that all your solutions will have I in it. So let's compute our discriminant. So first of all, I guess make sure, is this in the quadratic equation form? Yes, because it's in descending order. So if I quickly determine what the discriminant is, we can say b squared minus 4ac. This is equal to 3 squared minus 4 times 1 times 4. Okay, that is 9 minus 16. 9 minus 16, that is negative 7. Negative 7 is less than 0. So we know that both of our solutions for this quadratic should be complex. All right? So now let's go ahead and solve. So the very first step that I look for when I'm solving a quadratic equation, because there's essentially 3 ways to solve it. The first way, and the one that you should always check first, is to see if you can factor this out nicely. So are there 2 numbers that multiply to be positive 4 and add to be positive 3? In that case, it'd be no, because you have 1 and 4, which add to be 5, and you have 2 and 2, which add to be 4. So this cannot be factored nicely. So now I have 2 options. I can either complete the square, or I can use the quadratic equation. A good rule of thumb for completing the square, I always look at my b right here, and I see, is this even? Because if I did it on an odd number, we would have 3 over 2 quantity squared, and then we would be left with a fraction. I don't want to deal with fractions, and if you want to, go for it. You do whatever you want, but for me, I prefer not to. So with this example, I will not complete the square. I will use the quadratic formula. And because we found the discriminant, we kind of already did some work. So what is the quadratic formula again? It is x is equal to plus or minus, that is not the quadratic formula. That's not how it starts. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, again, so maybe I should write it down, kind of did it over here, but let's explicitly write it out. A is 1, B is 3, and C is 4. All right? So one other comment I want to make about completing the squares, you also want to make sure that this A is 1. So you can also see, so when I say B, check the B, essentially what I mean, check B over A first to see, is this even? Right? If it's even, then I would complete the square, because I think it's a lot faster after you get some practice done with. So now let's plug it in. So we have b, which is so it's 3. So this is the opposite of 3. And then we know b squared minus 4ac. We already established this above here that this is negative 7 all over 2 times 1. Right? So now, so what do we know? So if there is a negative, under our radical. What does that mean? We're going to pull out an I, and then 2 times 1 is 2. Let's bring our work up here. So I'm going to look at the square root of 7. So 7 is a prime number, so I can't break it up into factors, and it has a power of 1. So that means that our radical is as simplified as possible. So this is as simplified as possible. So what is our solution? Our solution, so x is equal to negative 3 over 2 plus the square root of 7 over 2i, and it is negative 3 over 2 minus the square root of 7 over 2i. And that is our solution. So keep in mind, so it says write solutions in complex standard form. That is why I could not keep it in this way. All right, so now let's do a second example. So we have x squared minus 6x minus 2. So first things first, I want to see, am I going to have 2 real solutions, 1 real solution, or no, or 2 complex solutions, right? Or just no real solutions. So I'm going to plug it into the discriminant. So b squared minus 4ac. Remember, this is the expression under the radical. Okay, so what is a, b, and c? A is 1, b is negative 6, and c is negative 2. So we want to compute negative 6 quantity squared minus 4 times 1 times negative 2. When we do that, we get 36 minus or plus 8. Right. So, and this is 44. Yeah. Right. 44 is greater than 0. So what does that tell us? That tells us we will have 2 real solutions. Right. But keep in mind, so I know it can get a little confusing, but because if you look at that chart I gave you guys, real solutions are also complex solutions where b is 0. Right? So I will solve this 2 ways. Okay, so first of all, I guess the first thing we have to do is we have to see, are there 2 numbers that multiply to be negative 2 and add to be negative 6? And that's no, because so since 2 is negative, I have to do negative 2 and 1, or negative 1 and 2. But when I add those, I will get 1 or negative 1, which is nowhere close to 6. So we can't just factor this out as is. So now our options are to complete the square and use the quadratic formula. Right? So I'm going to complete the square. Why? Because my b over a, so negative 6 over 1, that is positive, and not positive, sorry. It is even. Since this is even, we can easily complete the square, right? But then on the second, and then I will also show you guys the quadratic formula, because this is what this section is kind of emphasizing, and I'll just show you that either method will give you the same answer, right? So if we're going to complete the square, I have this x squared minus 6x minus 2. So the first step would have been to multiply both sides by a, but a is 1, so we don't have to do that. What am I going to do next? I'm going to keep all my variables on the same side. Right, so I'm just going to add 2 to both sides. Now I'm going to complete the square. So I'm going to take this negative 6, I'm going to divide it by 2, and then I'm going to square it. When I do that, I get 9. So I'm going to add 9 to both sides. Right. So then this should be a perfect square trinomial, and it is. It goes to x minus 3 quantity squared. When we check our work, we will get x squared minus 6x plus 9. And this is equal to 11. Then I get x minus 3 is equal to plus or minus the square root of 11. 11 is prime, so there's no factors that can separate it. Or you can't multiply it can't be a multiple of prime factors, because it already is. And it has a power of 1. So therefore, this square root is as simplified as it can be. So I'm just going to add 3 over, so I have x is equal to 3 plus or minus the square root of 11. So, adding one more step, so we have two solutions. We have x is equal to 3 plus square root of 11 and 3 minus the square root of 11. And as you can see from determining the discriminant, this is true because these are both real solutions. There's no I attached to them. So this is how you solve this example. But now what I'm going to do, so I'll go off to the side. So I'm just going to bring it over to the side right here maybe. Erase this. Right, and I'm going to rewrite our problem. So remember, we are solving x squared minus 6x minus 2 is equal to 0. And we already determined that the b squared minus 4ac is 44. Right? So now this method, I'm going to just use the quadratic formula. Right? So what is the quadratic formula? The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? So, and we already established what a, b, and c are. It's up there. So negative b. So this is so negative b, I really mean the opposite of b. So what's the opposite of negative 6? It is positive 6. Plus or minus, and then we already determined b squared minus 4ac, that is the square root of 44. All over 2 times 1. Right, so 6, and we have 2, this is plus or minus. So the square root of 44, so when I break it up, this is 4 and 11, and this is 2 and 2. Right, so this can be 2 squared times 11. The factor, or the power of 2 is equal to our index, so that means we know that this can be simplified more. So this gets simplified to plus or minus 2 square root of 11 all over 2. Right, so I guess I can just bring my work over here. So now the 6 and 2, they both have a 2 in common, so I'm going to factor that out. And when I factor that out, I get 3 plus or minus the square root of 11 all over 2. So since this is multiplied, okay, so this 2 is a factor, this 2 is a factor. So now we can reduce it to 1, and then we'll get 3 plus or minus the square root of 11. So therefore, x is equal to 3 plus square root of 11 and 3 minus the square root of 11. Okay, so as you can see, we get the same solution, whichever way we do it. But I want to, but the reason why I like completing the square more is because you can see less steps, and you just have to, so for completing the square, you just kind of have to understand the method. Like completing the square, your goal is to make this a perfect square trinomial. How do you do that? You take that b, you divide it by 2, and you square it, right? And then you can just solve it as is. But then for the quadratic formula, you have to memorize the whole formula. Then you gotta plug all the numbers in, and then you have to do some simplifying and all that fun stuff. So if you want to do this, that's fine. But I just want to show you guys side by side that this is actually, in my opinion, it's less work. So